Hey guys, tonight we're going to be talking about how to multiply with decimals. So we're going to talk about sometimes decimals and whole numbers and decimals with decimals. And the reason why we're throwing them all together, it's 2 lessons from your book, is because the rules are the same for both of them, okay? So let's start with the title. We are doing lesson 3-3 and lesson 3-4, and we're just going to call it multiplying with decimals. Now, those 2 lessons have their own names. When you look in the book, one's multiply decimals by whole numbers, and the other one is multiply decimals. And I'm just going to call them together multiplying decimals. Today's date is 9/13/18. Okay, so what we talked about before when we were adding and subtracting, it's always a good idea to try to estimate first. But remember how I kind of threw it in as an afterthought? So today I'm going to try to put it in the right spot. So that means first thing you should try to do is to estimate the product. Now, why is that important? This time we need to make sure we get the decimal point in the right spot. And if we estimate first and we have an idea what the answer should look like, that will help us make sure that our decimal is in the right spot. So we're going to say it helps with decimal placement. Okay, and again, the whole point is I'd rather you figure out if you made a mistake on your own than wait until I'm grading like a quiz or a test and it's cost you points. So that's step 1. Okay, next we're going to do a little pretending. What are we going to pretend? Well, we're going to multiply as if the decimal or decimals don't exist. So multiply as if. And the reason why I say decimal or decimals, because there could be just one decimal in one number, or both numbers could have decimals. I'm going to use this parentheses and then the S. That means singular, or it could be plural. So multiply as if the decimal or decimals do not exist. Now, when I do multiplication, I'm going to do the same thing I did with adding and subtracting. I'm going to multiply vertically, and I don't line up decimal places, right, because the decimals don't exist, so I just make sure the last digit of each number lines up with the last digit of the other, right, and then the tens line with the tens, the hundreds, and so on. So I'm going to work in that vertical fashion, and you'll see in the examples that we do how to do it. So the multiplication is regular multiplication, nothing fancy there. Now comes the interesting part. We got to figure out how many digits are going to come after the decimal point in our answer. So it's a counting game. Okay, so we're going to count how many digits come after the decimal or decimals. And again, we're going to see these in the demonstration questions, okay? The examples. Count how many digits come after the decimal or decimals. So I'm going to use that parentheses S again. All together. So I look at both the numbers that were all involved, the original numbers involved in the multiplication problem, and I'm going to look for how many digits came after decimals all together. Okay, now what do I do with that number? That number represents how many digits have to come after the decimal point in my answer. Okay, so your answer should have the same number of digits after the decimal as you counted in step 3. So again, if you look here, we've got 1, 2, 3, so it's step 3 is the one that's going to go be how many digits come after the decimal point. Let me go ahead and erase all of that. Okay, so Again, if you have done that estimation step, you've already kind of got yourself ready for the last step, which is for check reasonableness. Check for reasonableness. Is your answer reasonable? And what would that entail? Your estimate should be approximately the same as your actual. In other words, did you get a 2-digit number? When you estimated you got a 2-digit number, is your product a 2-digit number as well? Meaning 2 digits whole number wise, okay? So, enough of my babbling. Let's get to the practice. So I'm going to switch my screens. Remember, pause anytime you need to slow down and see something again, or just shut me up for a while. But let's move on to do some practice. So let's go back to black, and the directions are just simply multiply. So I'm going to mix these all up so that your brain can get used to that. So we're going to start, and again, remember how I talked about your book likes to write problems horizontally, not because it's any way to set up the problem, it's because they're just being cheap, okay? So first thing I'm going to do is estimate, and what I would get is an 8 and a 4. So if I multiply those, I get 32. So my answer is going to be somewhere close to 32, okay? So it's a 2-digit answer. So that's what I'm looking for. All right, let's go ahead and set this problem up as if there weren't any decimals. Now, the best way to multiply is always put the shortest number on the bottom, because he controls how many rounds of multiplication you do. If you go the other way, you'd have to do 3 rounds of multiplication before you can add. All right, so then I multiply. 8 times 7 is 56. 8 times 4 is 32. 32 plus 5 is 37. 8 times 4 is 32. 32 plus 3 is 35. Now we're going to go back to the original problems, or the original numbers, I'm sorry. The first number didn't have any digits after the decimal point, but the second number had 2 digits after the decimal point. So what we do is we're going to move the decimal point to the left 2 digits so that my answer has 2 digits after the decimal point. Now, is 35, let's do a different color here, is 35.76 approximately the same as 32? And the answer is yes. So I feel confident in stating that my answer is 35.76. Okay? So that's your actual. The estimate just helps you, did I do it in the right way? All right, so I'm going to mess up with you guys because I'm going to go do problems that are now decimals and decimals, okay? So let's try this one. How about 4.12 times 0.05? Okay, so I'm going to round each of these to the nearest whole number. Now here's what's weird. The first guy is going to round to 4, right? The second guy is going to round to 0. So this is saying your answer should be, oh sorry, did I write the wrong thing? Your answer should be close to 0. So it's not going to be nothing, but it's going to be very small is what it's stating. Okay, let's get into the multiplication. Let's see, I have a 4-digit and a 1-digit number. So I'm put the 3-digit and a 1-digit number. So put the 3-digit number on top, the 1-digit on the bottom, and I multiply. I get 10, 5 and 1 is a 6, 5 and 4 is 20. All right, now I go back and I count. I have 2 digits after the decimal here, and I have 2 digits after the decimal here. So altogether, that's 4 digits. So my answer is going to be having 4 digits after the decimal point. So I start in the back and I move 1, 2, 3, 4 to the left. So what I'm comparing is 2060, or I can drop off that last 0. So I'm going to put a slash there. That means that 0 is optional, okay? If we're after a decimal point and we have zeros at the end of a number, we can drop off those extra zeros. So I could read this as 206 thousandths. Is that approximately equal to 0? And I have to say, that's closer to 0 than it is to 1. So again, I'm going to say yes. So I feel pretty confident that I did the math right. And I'm going to just leave it like this. I'm not going to include that extra 0. Okay? All right, let's go back and let's do one with a whole number and a decimal. So example 3. Let's see, let me find a good one. Ooh, this is a good one. 2.63, or 2 and 63 hundredths times 9. So again, I'm going to do an estimate. So this would round, the 6 is going to make that 2 up to a 3. I'm not going to round the 9, it's already a one-digit number. So I'm going to get, my estimate is going to be about 27. So I should get a 2-digit answer. Meaning 2 digits in front of the decimal point. All right, let's get to the math. So let's do 263 times 9. And let's see, we get 27. We get 54 and 2 is 56. We get 18 and 5 is 23. All right, now we got to go back to the original problem and count how many digits came after decimal points, original numbers, and I see 2 digits, and that's it. So my answer should have 2 digits after the decimal point. So the question I ask is 23.67, is that reasonably close to 27? Oops, sorry, wrong place for my question mark. Come on, friend. And the answer is, yeah, I think that's very reasonable. Both in the 20s, okay? Yeah. So, again, I feel really confident that my answer is 23.67. Okay, let's do another one that is multiplying both numbers or decimals. So let's see. Let's do this one. How about if we have 14 thousandths and we want to multiply it by 3 and 7/10. So again, we're going to start with our estimation. Here we are again, about 0 times about 4, and that gives us an answer that is about 0. So again, it's not going to be 0, but it's going to be closer to 0 than it is to 1. Okay? All right, that's what I'm thinking. So next, I'm going to go ahead and multiply. Now, when I get rid of all those extraneous zeros, I have a 2-digit number 14 and a 2-digit number 37. It doesn't matter what goes on top and what goes on the bottom. Now, personal preference, if I can multiply by ones, it makes my math really simple. So I'm going to put the 14 on the bottom. If I put the 37 on the bottom, the answer should be identical. So 4 times 7 is 28. We get 12 plus 2 is 14. Now the reason why I crossed this off is I have a 2-digit number, so now I have to go through the rounds of multiplication again. Don't forget, we're going to put a placeholder in our second round because we're actually multiplying not by 1, but by 10. So we get a 7 and we get a 3. So I add those up. I get an 8, I get an 11, I get a 5. Now I'm going to go back to my original problem, and I'm going to count how many digits came after the decimal points all together. So the first number had 3 digits. 3 digits. And the second number had 1 digit, for a total of 4 digits. So I go to my answer, and I move to the left 4 places. Now notice, that's where the decimal ends, and I have a loop that has nothing in it. So we got to fill it up with a 0. So, here's my question. Is 518 10,000ths, is that similar to 0? And the answer is, yeah, that's pretty close to 0. So again, I feel pretty confident that my answer is going to be 518 thousandths. Okay? So all the problems that you can do are just variations of these numbers, but the process is the same. All right, good luck tonight.